Welcome back and thank you for joining. We're going to take a look at combinations of transformations in the square root function indicated here. F of x equals the square root of x minus 2 plus 4. So first, we're finding the equation of the function that is reflection in the y-axis, which means that we're finding f of negative x. So what that means is that instead of x, now we're going to write negative x wherever x appears in the right side of the equation. So now we have the square root of, I see x, that will become a negative x and then minus 2 plus 4. So if you want to write this with a factored coefficient k, which is what we normally do before we start factoring, graphing a function, then we can take that out and we'll have negative 1 x plus 2 and then plus 4. So next we have the equation of the function that is reflection of f of x in the x-axis. So what that means is that the y values now are becoming negative y, or f of x is becoming negative f of x. So let's take care of this. Negative f of x is equal to, so negative, now look at f of x, root of x minus 2 plus 4. So we have open brackets here, root of x minus 2 and then plus 4, close brackets. Now I'm actually going to make the brackets red in here so we remind ourselves how important it is that when we apply a reflection on a function that is already in some transformed form, it is important that every term has to be reflected. So we have negative root of x minus 2 and then minus 4. Now, equation of the function that is horizontal expansion by a factor of 6. Horizontal expansion means that the value of k is 1/6. So we're finding f of 1 over 6x. So that means that this would turn into 1 over 6x minus 2 plus 4. Now, if you want to write this equation again with k in factored form, and that's what we want to do again before we start graphing. So that will turn into x minus 12 and then plus 4. Next, we have equation of a function that is horizontally expanded by a factor of 1/3. So that has given us the value of k directly. So that means that we're finding f of 1 over 3x. So wherever we see x in our equation, it will now be replaced by 1/3 of x. So square root of 1/3 of x minus 2. And then plus 4 at the end. So we're going to have f of 1 over 3x is equal to, again, I'm going to factor out 1 over 3. That's what we normally do whenever we are graphing or preparing to graph a function. So factor out k. So keep repeating this to yourself because it's a very common mistake that students make, so anyone makes. So next, equation of a function that is horizontal compression by a factor of 4. So that means that the value of k is equal to 4. Remember that our f of x is the square root of x minus 2 plus 4. So if we want to find f of 4x, which is a horizontal compression by a factor of 4, it means that we have 4x minus 2 and then plus 4. Again, factor out k, 4x minus 1 over 2 plus 4. So remember that when we take out the coefficient, we have to divide every coefficient in the existing term by whatever factor you take out. So 2 divided by 4, it will give you 1/2. Next, we have equation of a function that is vertical compression by a factor of 1/4. So we are trying to find in here 1/4 of f of x. Okay, so remember that the f of x, again, is equal to, just going to write it down so it's easier for us to make the comparisons, x minus 2 plus 4. So wherever this is going to be your f of x. So in front of the f of x, now we're going to have 1 over 4. So in brackets, the entire thing, we have the root of x minus 2 and then plus 4, close brackets. Now you want to write the equation in a more simplified form, which means that 1 over 4 will multiply every term inside the brackets. So 1 over 4 root of x minus 2, and then plus 1 over 4 times 4 is equal to 1, so plus 1. Now the equation of the inverse of f of x. So this is where things get a little bit more interesting. So we have f of x equals the root of x minus 2 plus 4. So xy notation first. Switch x with y. Isolate y one step at a time. Notice that when you are isolating a term, you kind of follow BEDMAS the opposite way. So you do the subtractions and additions in order to isolate, and then you do multiplications or divisions, whatever is necessary, or the powers, right? So we are trying to get y outside of the square root, so we're going to bring both sides to the power of 2, because the square root and the power of 2 eliminate each other. So we have x minus 4 is equal to y minus 2. So that makes y equal to x minus 4 squared, and then bring negative 2 to the other side, plus 2. So this would be f negative 1x. As you can see, this is a parabola that opens up. So if you were to draw the graph of this function, that's going to be a U shape. But when you draw the graph of this function, that is going to be simply one of the arms of the sideways parabola. So remember that here is when we have to start taking care or thinking of the domain. So if the domain of this function is, of the given function, is x bigger than 2, or equal to 2, and the range is y bigger than or equal to 4. How do we know this? It's translated 2 to the right and 4 up. So that's going to be a 2, and this is going to be, let's say, about 4 in here. So what that means is that the domain of this function will be x bigger than or equal to 4, and we're going to add this on the side because otherwise we won't get a reflection. We'll get more than a reflection of this function. So this would be f negative 1x for this square root function. Now equation that is vertically stretched by a factor of 3, remember that our f of x is the square root of x minus 2 plus 4. So if you have a function vertically stretched by a factor of 3, we're doing 3 f of x. So what that means is number 3 will multiply the entire f of x, so the entire square root of x minus 2 there, and then plus 4, and you close the brackets. And what we got now is 3 root of x minus 2. Remember that we're multiplying this in, plus 12, and this would be 3 f of x. So I hope you found these instructions useful, and thank you for learning with me as always. Bye for now.